Our exit ticket out of this section, then, I want to introduce, or not introduce, but we're going to come across three minor things as well in this problem that have been different before. So look for those three things. Can you see one of them right now? Well, I don't have any radicals this time, but rather I have an exponent. Yes, that's one thing. So we could, if we want to, we could rewrite this as the cube root of 3x minus 1 plus 4 equals 0. So we could do that. I'm going to show you that we don't have to do that here. The second thing that you may have noticed is that I have cube roots now. They're not a square root. So given that, I'll change the power that I'll raise that. All right. Now the reason why I said we don't have to do this one is we can solve that one with the same type of an idea. So let's begin with this, and let's isolate what would have been the radical, but in this case, the term to the 1/3 or the rational exponent. So this will become 3x minus 1 to the 1/3 equals minus 4. So I isolated the expression containing the rational exponent or the radical, and you can see if I did it, the radical would have been the same. This would have been the cube root of 3x minus 1 equaling negative 4. Similar idea. So in both of those, we're going to raise both sides to the appropriate power. Since they're cube roots, I'm going to raise both sides to a 3. So 3x to the first to the 1/3 to the third, that becomes a 3x minus a 1. And then negative 4 cubed, 4, 16, 64, equals a negative 64. Same thing would have happened here. Raise both sides to a power of 3. Bummer. That would have got a 3x minus a 1 equals a minus 64. Identical expressions. So here we can solve 3x. Let's add a negative 1, or add a 1 to both sides. So 3x equals a negative 63. X equals a negative 21. And there's my solution. Now the third thing that I wanted us to be able to identify is I don't have to check this solution for an extraneous solution, because we didn't raise both sides to an even power. We raised both sides to an odd power. And when that happens, we don't introduce an extraneous solution. However, it's a good idea to check because we may have introduced a mistake, and that's on us. So anyway, this is the end of that particular series of solving radical equations.